Welcome everyone to another machine translation webinar from Taos. My name is Milica Panic and I will be one of your hosts today. If we've set up things right, you should be able to see us on the side. So the people we have here today in the webinar are Konstantin Savenkov, the CEO and co-founder of Intento. We have our own David Koot from Taos, from the data side of the house. And also Janice Campbell from Adobe and Alon Labi from Unbabel as our panel leads and our co-chairs. So welcome, everyone. What we will be talking about today is a very kind of interesting and timely topic. And timely because there is a new report coming out very soon from Intento. So it is about the large-scale machine translation evaluation. And for those of you who follow Intento, you might know already about their the state of the machine translation reports that they publish every year. They've started in 2017, and in 2018 that they published a domain adaptive neural machine translation engine or evaluation report. In 2019, they evaluated stock engines, published another report on it, and what you are about to see today is a sort of a preview of the report coming out this year. It's as Konstantin will show soon, it's going deep, it's going wide, and it's very multidimensional. David Koot from Taos will explain how Taos partnered with Intento in creating this report and how we provided the test sets for this machine translation evaluation. As a part of the presentation, we'll go into a specific machine translation study on the COVID sets that Intento also did, and then we go into the panel with questions and answers. Before we start, I would like to remind everyone that this webinar is being recorded, so you will receive a recording after the meeting, and you will be able to replay and take an additional look at the content. As a part of the follow-up, we will also share a preview of the report that Intento will be publishing. One important thing is that we won't be taking questions during the presentations, but we will wait until the very end to start a panel. So stay with us until the end. Submit your questions through the chat or questions module in GoToWebinar. And well, I hope you'll enjoy this. So with that, I would like to give the floor to my colleague, David, to walk you through the how Taos provided data to Intento for this machine translation evaluation.
Okay, thank you very much. I'm going to all right. Okay. Yeah, my name is David Koot. I work at Taos in the data team. This is my first webinar here for the machine translation part. Maybe some of you know me from the DQF webinars, which I sometimes was a guest into. But now we are going to talk about this this report and this research and our collaboration with Intento. And I want to show the part that Taos was doing in this research. So we know Intento, of course, of these of their research and the reports on machine translation, and I think it was in autumn last year that we got the idea to collaborate on the next report. And well, we actually we struck a very simple deal. Taos would be the provider of the data, and with that, Intento could do their interesting research. Now, we were very enthusiastic to do this. I think Taos is the right organization to provide this data. We have, as with the data cloud, we have a big amount of data. We got diverse data, and it's of good quality. So I think this is the right amount of data to start this research with. And we also had this idea that this would be some kind of a standard test set. And the way we went through it, well, I will show you how that all happened. First of all, this data came from the data cloud. Now, if you have been watching a previous webinar, we were also talking about the data cloud repository. You might also have heard that data cloud as such is at the end of its life cycle. It will be retiring, but there is still this big repository of language data, and we use this repository for this research. Now, a little bit back to the history of data clouds, because this goes back a long time. Actually, it started in 2008 already with the Taos Data Association, and the idea was to, well, very idealistic idea, to share your data. If you're sitting on a lot of data that you have been using during translation, why not share it with others, just on condition that you can also get data from other sharers? And that was the start of this what eventually became the data cloud in 2012. The data cloud is still ongoing. It took a lot of it had a lot of traction. There were a lot of uploads to this data cloud, and actually, well, I'm still working in this database, and I'm actually always impressed by the sheer numbers of this repository. We're actually talking about around 35 billion of words, with over 1,000 language pairs. Of course, it's a little bit dependent on how you count, but that's the sort of order that you have to think of. So it is big. It's very diverse. We'll talk about it a little bit more in the next slide, and it's also of good quality. And well, I can say that it's not really taken for granted that such big repositories are of good quality. Many of these repositories are coming from data crawling, from web crawling, and yeah, that is not always the best quality. But the data in data cloud is, of course, it's not flawless, but it's production data, and well, you can see that from the quality. We sort of have the luxury that whenever we want to go into the data and we want to, well, we want to divide the good from the bad data, we can actually assume that the data is good, and we write some algorithms that might get out the bad data. Whereas for many repositories, for web crawling repositories, it's actually the other way around. You have this big lump of data, and you are just trying to get out what is good, and end with that. About the well, the categories, all the different domains that is in the Taos data. We have two types of paradigms how to categorize our data. The first one is, well, the classic one, the a priori categorization of that you go and sit back, you look at your data and you try to figure out what kind of data is there. And we have the industry tags in our data, and we've got content type tags. Industry, you just have to think of the sector that generated this data. So I'll think of pharmacy industry, the IT industry, or maybe leisure and tourism. That kind of metadata you're talking about if you look at industry. And content type is more the linguistic context of the data. So in that case, you're talking about maybe is it marketing material, is it user instructions or user generated data, that kind of categorization. Now, I just sort out, I dig into the data and I came up with a few examples. So this is a sentence that I found from English to some other languages. It says this service is only available for those configurations deemed customer installable and applies only to Windows configurations. And the uploader has tagged this as computer hardware as the industry, and the content type is sales and marketing material. And well, it's perfectly clear. I mean, I can see this as being well a piece of text that comes in a leaflet and is a footnote to a table, for example. So the tags are, well, are pretty valid, I'd say. And there's another sentence which goes like, this assurance is usually only available when the risks and reward have passed to the enterprise. This is a completely different industry. It's professional and business services, and also the content type, it's financial documentation. But as you can see, it's coming from different industries, it comes from different content types, but there's a lot similar in these two sentences. And this is interesting because if you want to train machine engines in, for example, patents or the jurisdiction text, then these two sentences would both be relevant. So this is the other way of categorization that we use nowadays, the other paradigm, which is more a free form, what we call the matching data. And that's more based on similarity. You take your corpus, you say, okay, this is the kind of data that I'm looking for, and you can tag other sentences according to the similarity to this corpus, and that is what matching data does. And it's always these two types of categorization that we use in matching data. Now, for this research, we were after a good amount of data in a lot of different language pairs, and also in different domains. So we took the domains from the industry metadata, and we took different languages. So in order to have a good amount of data, we from each subcategory of language pair and industry, we took 7 segments in total, which was based on empty alignment. So that was the selection, the first selection type, and from this we wanted to clean it up to get only 500 segments. For this cleaning up, we have different filters. We looked at the length and the length discrepancy between source and target. There's some features that we looked at in order to have reliable translations there. there was we searched based on keyword selection, so we have the right domain, and that eventually left us with quite a number of languages in which we had 500 segments for each of these domains. And that was how we provided the data. And I guess it's now over to Konstantin to provide us with the rest of the story.
To go very much into the actual evaluation. Konstantin, you should be able to share the screen. Thank you, David.
Okay.
Yeah, so this is how Taos provided a test data sets.
Thanks, David. Yeah, do you see my screen? Yeah.
Yes.
Yeah, so as Nilsa said, we did lots of reports before, but they were done on general purpose data, so it's like news, and also on public data. And the thing was, we've seen that also results we get from these reports are very different from what we get when we do evaluation for enterprises. So we wanted to explore it more and to provide more guidance to enterprises by doing this evaluation data which enterprises work with. So just something to start with is the machine translation landscape is quite complex, and it grows. Just over last year, I think we've seen 11 UMT vendors with pre-trained models coming from different sources. Some of them, they were more like NMT shops doing models from scratch, and they decided to provide them from the cloud as stock models. Others just new companies. And then we see more ways to customize those models through domain adaptation, automatic domain adaptation, through glossary support. So we want to provide some initial guidance in this landscape so that you know what you can start with. And we run to, besides like around 150 reports, which we cannot share because they were run for specific companies, we run 2 public reports which we can share. And one of them is this white report on this amazing data set David told us about, which covers 16 industry sectors, 14 language pairs, and 15 stock NMT engines commercially available. And since this wide, so it's overall it's 128 industry and language pair combinations, quite a lot. Since the scale, we could only automatic scoring. And this time we also explored how we can make it better by using slightly different automatic scores. And then second, also Taos published recently COVID data set, which is large enough to try training the engines on it for several language pairs. And we made another sort of deep report where we actually trained 4 to 5 different domain adaptive engines for every language pair, and also pooled around 12 stock NMT engines. And instead of just, besides using scores, we also appealed to LSP community and 8 LSPs volunteered to do human review. So those are 2 reports, which actually Taos report we're launching today, and it should be already published. I don't know, hopefully. COVID will be published a bit later. And that's what I want to talk about. So Taos, this industry-specific report. We wanted to answer a number of questions. So first, by comparing how MT works on different industry types and content industry sectors and content types, which one are easy or which one hard for machine translation. Because there are certain assumptions on the market that marketing is hard, documentation is easy. Wanted to validate that, and also to see for what cases there is a number of engines providing comparable level of quality, and for which ones you need to be really careful with empty choice because it's hit or miss. Then how many different systems you need to combine to get the best quality across all these different cases. Well, then finally, which MT to use for every specific case when you cannot invest in tailored evaluation. And also at Intento, we have this thing called smart routing, where basically you can send the data without specifying MT provider and just gets routed to the best one. So currently it's based on this general purpose corpora, and we want to have domain specific smart routing, which also we will set up based on this report. So data set, well, David covered that. Just some statistics. Overall, we got from 2,000 to 8,000 segments per language pair. And 16 industry sectors, if we don't count undefined. And you see it's from 4 to 15 industry sectors per language pair. And on average, 500 segments. We did some additional cleaning, which could remove a dozen of segments in every domain. And if you look at content types, there are 8 content types. They are unevenly distributed because we didn't control that. So we did not, when we asked for data, we didn't thought about content types. So we also analyzed what's happening in content types, but as you may see, in some cases, we have just 2 segments, say policies, process, only 2 segments for Korean. So we obviously did not drive any conclusions for Korean. So here we analyzed only content types where we have at least 500 segments. Now the engines we evaluated, they're listed here, like 2 models from Ali, Amazon, Baidu, DeepL, Google, JT.com, Chinese provider, IBM, Microsoft, others. I need to say that some of them provide additional customization features, such as automatic domain adaptation on translation memories or glossary adaptation. We've marked it on this slide to our best knowledge. I must admit that this changes very often. Like glossaries on DeepL appeared very recently, and they're still, I think, of limited availability, not through an API, but we still marked it. So we could make some mistakes here. Let us know, we'll fix it. Then we looked what scores we should use. So typically we use LeapOR. And LeapOR is, it's like Blue, but it works quite reliably on segment level because we need to be able to run analysis on segment level. The problem with scores like Blue is that they're based on text similarity, although they're clever, but still. And it's syntactic similarity, meaning that if you have alternative translations, they consider them different. We looked at other scores. We looked at their score, which is based on multilingual embeddings. And they're built in such a way that if you have 2 alternative translations, they point to the same point in the vector space, meaning that the Cassin distance is between them very small, so they're similar. And indeed, we've seen that segments which get low LeapOR and Blue scores because it's alternative translations, they get high BER scores. So we decided to use this one. It still has some issues if the reference translation was wrong. BER score can't really do anything with that. We looked at also score recently published by Google, which is called Blurred, which sort of trained Blue. We were unable to use it here because we have language pairs from English to other languages, and blurred currently works only into English, so we'll try it later at some point. There's another good score called YISI, which to my shallow understanding works in a way that it first it does part of speech tagging, so it sort of understands sentence structure, and then it analyzes similarity in equivalent parts of the sentence between different languages. But sadly, the available versions didn't work for us. So the most advanced version available open is YISI-1, which use word-to-vec embeddings. And word-to-vec embeddings, they work only on general domain. So we tried it, and for, I think, well, many words in this in-domain content, they were marked by word2vec as unknown token, so single token for all of them. And another version of YISI, which is based on BERT embeddings, it's not publicly available, so we skipped it for now. We also tried to work with MTQE scores, which basically analyze not similarity between reference translation and machine translation, but between source text and machine translation. We found they don't have obviously issues with wrong references. So if it's a right translation, they mark it as correct. They don't care about wrong human translation. But we found that they have their own nuances around working with alternative translations, and also biases such as different tone of voice and different gender. So for now, we are unable to make them work reliably for evaluation. We're also postponing this research some later point. Now, how we did ranking. So we used BERT score, basically. How we did ranking. That is why we work on segment level, to be able to calculate confidence intervals. Because if one engine is better than another, if it's better, 0.0001%, it may not matter. It may be to similar engines. So we calculated confidence intervals, and we have a link in a report on sort of specific approach to that. And we considered best engines ones which have interval overlapping with the highest ranked engine. So it's not only the best one, the top one. And first of all, we calculate the score on language pair level. And you see here, well, a couple of nuances. So you cannot really compare reference by scores between languages. That's why it's all colored in one color. You cannot really compare them. If you have 0.8 in Chinese and 0.5 in German, you cannot tell that. You cannot say that in German it's weaker. So then we found that it's 4 engines. 7 engines got into best overall for language pairs, and 4 engines enough to cover everything. However, we must note that this, since it's in-domain evaluation, this analysis on language per level is pretty useless. Because as you have already seen, for every language, we have a different mix of domains and different mix of content types. So there's no point into looking into that. So what we looked into is how engines perform across different industry sectors. And what you see here is a very complex picture. And so it's normal, scores are normalized across language pairs, meaning that, again, if it's light blue for Chinese and dark blue for light green for Chinese and dark green for Turkish, doesn't mean that Chinese translation is worse, because you cannot compare scores. But what you can compare, you compare scores in one language. So if it's darker for consumer electronics in Turkish, probably it's translated, it's closer to human translation than automotive manufacturing for this language pair. So machine translation, it's easier for it to work with this domain. You may also notice that for many cases we have multiple comparable engines, which means most likely that we didn't have enough data for this domain to derive this conclusion. You may see that, say, for English to Chinese, leisure, tourism, arts, 9 engines provide comparable level of quality. They got into this best part, but in the same time, it's the weakest level across all Chinese domains. So probably just we didn't have enough data to drive final conclusion. Although in other cases, you may see that there is just single leader, so had enough data. Overall, what we see, we run what's called set coverage problem on this data, and we found that despite of all 15 engines pop up somewhere as best one, it's enough to work only with 7 of them to cover everything with the best quality. And if you pick one specific industry sector, it's enough to work from 1 to 4 MT engines to get the best quality for all these language pairs. And we found that MT deals quite well with computer software, legal services, and telecommunications across all language pairs. You may see that these columns are relatively darker, although for professional business services, it's not that good. So for almost every language pair in this domain, we have a relatively weak result. And then for some languages, such as Chinese, French, Spanish, and Russian, we have multiple comparable engines, while for others, such as Turkish, Japanese, and Finnish, you have to be really careful, because if you use a different engine, you may have significantly lower results. Yeah, we don't list name of the engines here. You can go to this page, and I hope it's read online, and you can get a full report with engine names and stuff. So then we looked at content types, and here we looked only at content types where we have at least 500 segments. And for others, I mean, if we added this content type where we have 2 segments or 5 segments, we would see that all engines are comparable, because the confidence intervals are so wide that they're all in one band. So we see here 6 engines, enough to cover to get the best in this best category for every content type. And again, it's 1 to 4 to cover all languages and select a content type. The easiest for machine translation, as you may see, are software strings and documentation, support content, and policies and processes. And for sales and marketing and instructions for use, it's hardest. So again, it may be hardest because that translations are less straightforward, human translations, but that also what creates a difference and challenge in practical use. Because for these domains, you typically have some very specific tone of voice and brand voice requirements, which you want to be met. Yeah, so some notes here. Obviously, if you have a different data set mix, you'll see different results. Then we run this report on plain text. While for some domains, you have inherent formatting, like some tags. And if you will run this on text with tags, you will see slightly different results, sometimes not slightly, because tag support is very uneven. Even for single MT vendor, inline tag support is very different across different language pairs. Like, good luck with Chinese. And then if you do customize, you will see different results, because if you add a glossary, if you train it onto your TM, you'll see that some things get better, other things get worse, and the ranking will change. So yeah, again, if you work with more languages, you'll see you need more vendors. You may see I put here also one page from a real world project from which we just presented at Koot, where we see for 19 language pairs we need to have like 7 engines for sport content and 5 different engines for product content. Then, yeah, so this report gives you an idea where to start with. You see your industry content type, you see your language pair, so you see what engines you may start working with and try if there any of them good enough for you. If not, you see which of them you can customize, and then you can sort of invest increasingly more to see ROI on this customization. So that's all with this report. How much time do I have until we go to questions? Please, can you tell me?
Good. Yes, of course. You have actually 15 minutes.
Good. Then
Very
I will.
well on time.
Good. So second study which we made is this deep study on Koot corpora. How it was built. We took corpora. We took 5 dominant adaptive engines and 12 stock engines, plus we experimented with glossary adaptation because we got actually medical glossaries from one of the LSP partners. And we used segment-based scores for filtering content so that reviewers have to review a little bit less. And as a result of this filtering, we got about 1,000 words per MT engine for post-editing and LQA. Also, we identified potential NMT quirks using segment-level scores. I'll tell more about that. And also, we had a full document for holistic review. And basically, these 3 types of things to look at, they identify 3 different angles which you may look at machine translation depending on the purpose. So if it's post-editing, you definitely need to just do post-editing, look at effort saving. If it's real-time raw machine translation, you want to be at risk-free, so you want to use an MT engine without weak spots, which provides stable translations. And if it's things like gisting, you want it to be consistent on document level. And we had 8 amazing LSPs who helped us with this linguistic quality assurance and post-editing. And then what we got estimation of effort saving and post-editing distances for different engines. We wanted to look if those are correlated, and we wanted to see where we need custom NMT, where we can go well enough with stock NMT, and also to get some guidance on what MT to use for those domains, and also to add specific routing to our system so that companies and LSPs which need to use MT for this type of data, they can just reuse the work already done for those evaluations. So we had 8 LSP partners for different language pairs. Sometimes we had several LSPs reviewing for one language pair. When we had one LSP, nevertheless, they provided several reviewers so that we can look how the judgment is correlated to filter out, reviewer disagreement. And the source data, we had several hundred source segment, 700,000 source segment per language pair. We did filtering on our end, and it was quite. I'll tell more about that. And we extracted 4,000 segments to test set with reference translations. And then we got sort of found an author of one text and asked to use this text for as a document for holistic review for this report. And I must say that, so the corpora is, I would say, is general medical corpora, and the text for holistic review is a COVID-specific text because there are some new words, MT engines we compared sort of about the same set of stock engines as in previous study, and 5 engines which provide automated domain adaptation. It's Google, IBM, Microsoft, ModernMT, and Yandex. And probably at some language pairs we had less, and some we may even had more. Probably had also JTCOM for Chinese. We looked at several corpus level scores. How we use corpus level scores is just we see if they're correlated, because they're calculated a little bit differently. So if they're not correlated, it tells us that we need to consider more top running engines, because there may be different errors between them. And we used segment level scores to do this filtering on segment level, reporting term. So you see, we didn't use BERT score here because the first time we used BERT, it's actually in this wide study. So overall, how the evaluation looked like. So we made cleaning of the data. We left with about 300 to 500,000 segments for training. So we did training. We analyzed what's happening during the training. We did some additional cleaning based on that. Then we ran weak spot analysis, getting I think actually several hundred segments where we expected to have some mistake from one of the engines, and we used segment level scores for that. Then we ran post editing and ran holistic review, and in the end we had sort of four dimensions where the engines can be ranked. This holistic review rating, then post editing effort and distance, and then this number of quirks. So we had quite complex cleaning workflow here, ranging from just duplicate detection to some advanced stuff. So we used MTQE, we used BERT, we used laser to filter out wrong translations, and also to filter out out-of-domain data, because we did clustering of text by domains, and we looked which we need to remove. We found that for some language pairs, we got lots of actually non-medical texts, but with some medical keywords, like ones you see here. In some cases, we filtered them where we could. In some cases, we probably was not able to do that. So for when we do training, what we did, we actually looked how segment scores changed after the training, so that we can see what got degraded, what got improved, and we can iterate with data. Then still, 4,000 segments per 15 engines is too much for review. So what we did, we filtered out top running engines, like ones which show highest scores. And also, we identified 2 samples. As I said, we pick these weak spots, which are basically a segment which is translated close to human by many engines, but 1 or 2 engines are translated very far from human. So we expect they have some quirk. It's either alternative translation or some issue. And then we sampled a very, very typical segment, not too far, not too close to human, something you get day to day for this post-editing, trial post-editing. So for weak spots, we took those and potential problems identified automatically. We brought them to reviewers. Reviewers validated them. For every engine, we've seen which one of them is a major and which of them are minor, such as it may be wrong, some translated DNT, proper noun, sort of considered minor. And then you may see that we had the different types of problems, empty problems found in different language pairs. For example, French, we had tons of problems with tone of voice and style. And for Chinese, there was a specific issue with the wrong punctuation when European punctuation is used in Chinese translation. And then you may see that we found different quirks in custom and stock engines. So in stock engines, relatively more untranslated words, because probably it was Indominant word, so this engine thought it's probably something non-translatable. And in stock engines, we had relatively more emissions. It's like a very typical issue for custom NMT. So results, actually said it. So yeah, one of the sort of exotic things is one of the engines translated produced traditional Chinese instead of simplified. And yeah. Then post-editing. So we asked post-editors to do post-editing, but also to identify perceived effort. So how much time, how much effort they think was saved. And also analyze the reviewer agreement to see, where's maybe some subjective. So we send them some scorecards, and we shared this they had to rank a segment in 5 different categories, like perfect, don't need to be changed, good, can be changed, can be not changed, not very hard to change, fair, which is basically similar to editing fuzzy TMH or human translation, and bad, meaning that it's really, you see it's machine translation, you need to edit it heavily, but still you save some time, and then useless. So we confirmed with reviewers expected effort saving, so that when we multiply those coefficients to these rated segments, we get expected effort saving. In parallel, we looked at post-edit distance. So for full document translation, there are 2 main factors which make it different from segment level review. One is inter-sentence consistency. And second, since we translate a document, like Word document, it has some style tags inside. So tag handling also influences those translations. Now, as a result, we got for every language pair, we got 4 dimensions, and we got engines ranking these 4 dimensions. And we try to cut in the middle, basically to do some trade-off where those rankings are not correlated, to pick something which, combined is on the top. And in real life, as I said, depending on the purpose of the machine translation, you prioritize one over another. If it's gisting, you prioritize holistic review. If it's post-editing, you prioritize obviously effort saving. And if it's raw machine translation, then it's you don't want to have lots of quirks. So we got quite good. Yeah, finally, effort saving is comparable between language pairs because it's about saved time. We got quite good, from 65 to 80% estimated effort saving for the editor. And you need to mind that there's also some other project management overheads which are not solved by that. We also find interesting thing that human translation did not get the first, and for every language pair we went into deep discussions with LSP to analyze what's happening, and we really appreciate how they helped us to figure out. We found that there are some specific things. For example, for French, it turned out that lots of corpora are in French Canadian, while reviewers were French European, and for them to edit French Canadian to French European, it took more effort than to edit machine translation French European to to proper quality. And in some cases, it was about that some two localized translations that, again, a reviewer didn't agree with the original translation, how it should be translated, did quite lots of edits. While with machine translation, it's very straightforward, it's hard to disagree. And obviously it was all blind, meaning that reviewers didn't know where machine translation is, what machine translation, where human translation is. Then we also looked at different post-editing distance per word. It's not comparable across language pairs, and also we found it's sometimes, very often, it's not actually correlated with effort saving. So sometimes the edit distance is high, but it's not. It didn't take too much time to fix it. In some cases, there was very subtle changes, but it took a lot to get to them, to make them. Now, the results here, actually it's not what we expect. So we expected that custom engines will be winning in every of those domains. It was not the case. So custom engines won, overall it was 6 engines, different engines winning. And only in 2 cases there were custom engines. It's English to Italian and English to Russian. In other cases, our stock engines produce better result. And again, so that's because the medical domain is quite wide, and probably we do not know how to properly clean the data in such case. So most likely what we needed to do, we needed to actually do very deep clustering of the data, and then pick the cluster which try different clusters, find the one which moves baseline engine to right direction. But if we realize that pretty down the road. But anyway, it's yeah, and I think we found that glossaries don't really help here, because glossaries we had, they were linguistic phrase glossaries, and the way machine translation applies glossaries, it's quite simple, so it actually leads to improvement. Now, notes here. Yeah, I said when data came from different sources and when the domain is broad and those subdomains share common keywords, you really need to be really sophisticated about cleaning. And domain adaptation always worth exploring. It doesn't always deliver the best result. And in some sense, if you get still such a good result that you can save like 60% effort with stock engines, is great. And then we found that during training, scores tend to grow, and that's basically how machine learning works. It grows the score, but quality doesn't always grow with the scores, which we've seen very clear here. So that's pretty much it. This report also provided quite interesting data, which we may use later to analyze what's called post-edits, to analyze what actually was preferred post-editing to compare it with human translation. And another thing, we want, with this wider report, with many industries, we actually want to repeat this type of evaluation with humans. So we're actively looking for also LSP volunteers for that. Yeah, that's it. Sorry for taking probably longer.
No worries. This was very insightful, and as we said at the beginning, multidimensional. So keep up the good work. This report, as we said, is soon to be available. I believe already tomorrow, if I'm not mistaken.
It's available. It's available today.
Yeah, it's available today then.
Somewhere. Yeah, there's the link
at the very beginning. But if you didn't catch it, we'll share it in the in the follow-up of this webinar. So yeah, maybe we should just go straight into panel. And if please keep on submitting the questions from the audience. We want to hear also your thoughts and if you need any clarifications on this. But now, Alon, Janice, do you have any immediate thoughts on this?
I have like
I know you have a comment on the score or the automated metric.
Well, yeah, I have a question and sort of a comment about the challenge of automated metrics these days, particularly dealing with machine translation engines that are high performing, neural MT engines now that are starting to get to be really high performing, and the standard metrics have been really not doing well at capturing those nuances, as particularly in terms of correlation with different types of human judgments, as we've seen this on the MT metrics task at WMT, and also in more practical settings like you articulated very nicely. I really enjoyed the presentation and the depth here that you provide, but you articulated the challenges of evaluating with automated metrics and the ones that you chose to do. So I wanted to ask specifically about in this COVID deep study where you actually did do LQA. Were you able to see with the automated metrics that you did use whether the rankings or the distinctions that you saw from the automated metrics actually correlated well with the human LQA analysis that you did in that context? And I'll put already my comment here also. That we've been working on this challenge of developing a new state-of-the-art automated metric for MT, and just to give a teaser, given all the challenges that you put out, we have a metric that we call COMET, C-O-M-E-T, that we've been developing at Unbabel, that we plan to release as open source later this year, and the results that we're getting as evaluated on the open data from WMT from the last couple of years has been extremely positive and promising, basically outperforming all of the metrics that you've indicated that you've tried out here, including BERT score and Blue Earth that have come out this past year. So we're very, very excited about it. And stay tuned. We'll make that available to everybody to try out.
Yeah. So what I can say here, with these studies, when we have LQA, we do very, very conservative filtering, because we have like 15 engines, and actually we send to LQA 8 to 10 typically. So what we're looking for, we're not looking at having a best by score. We're looking at where the Plato ends, where the we have this Plato of scores, and then there's sharp drop off, and then next engine is like 30% less. So we never, sometimes we try to do LQA for these engines which are really far, far away. We never found good results for them. Mm-hmm. But if you look at this Plato level, yeah, we see different LQA results, and specifically, as I mentioned, that happens when we do customization. It was just technically the way training transfer learning works, it improves the score. There's like gradient descent, and it improves the score. It's very, very rare cases it doesn't improve the score. You need to do really something really, really wrong to make it. But it's not always improvement in a direction which perceived as quality improvement. That's for sure. And addressing this thing, so we have our own roadmap with scores, and how we realize ideally what we want to do. We want to triangulate. We want to have 2 MTQE scores, one from source to reference translation, one from source to machine translation, and then score between reference machine translation. So we look at this triangle, and then based on that, do something. If you already did that, we're just happy. We'll assign our linguist to something else.
Yeah, no worries. Stay tuned, and we can follow up also just directly with you guys, and we'll tell you more about what we've done.
Yeah, good.
Yeah. Well, we actually came to the end of the webinar. There was one very interesting question from the audience. I'll put it out there, and maybe we can, Konstantin, you can follow up with the person who asked the questions, that specific question, and that was about well, one of your last slides showed that stock engines sort of beat, in a very general sense of a word, the custom engines. So they were wondering, like, how do you see the sort of the market for custom engines or customizations in the future?
I can just
Actually, that was going to be my comment as well, about the
Yeah,
custom
so maybe
versus
like,
stock. It's like
yeah.
we're overpaying, you know. So anyway, it was a great webinar. Really look forward to reading the paper and everything. So thank you very much.
Yeah. Thank you all very, very much. We'll follow up with more questions later on over email if you'd like. And we'll see you again on November 25 or 25th, when we will be talking about the data cleaning and clustering tools. And in the meantime, if you need more data, explore the TAOS data library. We have a lot of in-domain data sets across multiple language pairs. So with that, we would like to thank you all, especially our speakers and our co-chairs, and we are wishing you all a great rest of the week and a healthy rest of the week. So yeah, stay with us for further updates, and see you in the next webinar. Bye.
Thank you.
Thanks.
Thank you.
Thanks. Bye.